say it complete, right? In the eventual video, your question won't be there, right?
Right.
Yeah.
He'll
Okay.
take my voice out, but
Yeah. Okay.
Craig will
Understood.
add his voice. So
Oh, I see. Okay. Yeah. I just looked at one.
if we need some,
I looked
yeah.
at the one with the David Rothstein, I guess, in the forest, bioenergy one. Cause I
Yeah,
haven't
I
seen that.
actually, I interviewed him, but you never heard my
Sure.
voice, right?
Yeah.
Correct.
Yeah.
Okay. Just start with your name and then spell it for me, please.
Stephen Hamilton, Stephen Hamilton.
And what would be your title?
Professor, Department of Zoology and Kellogg Biological Station.
Okay, and you can just look at Holly and she'll ask you the questions.
Okay.
Okay, can you tell us a little bit about where we are and how it relates to Kellogg Biological Station?
This is a field experiment with different cropping systems, which is part of the Great Lakes Bioenergy Research Center. And that center is a partnership between Michigan State University and the University of Wisconsin, funded by the U.S. Department of Energy. The purpose of the center overall is to investigate how we might be able to make what we call second generation biofuels, which are biofuels made out of the whole plant. They're also called cellulosic biofuels, which is very different than the kind of biofuel we make from corn grain nowadays.
So tell us a little bit about what you have growing here and what are you exactly looking at, what species?
We set up the field cropping system experiment in 2008, and we've planted the candidate species that people thought would be high yielding in this climate and environmental setting. And we also grow traditional grain crops for comparison or for reference. And so right here we have hybrid poplar, very fast growing, but it produces a woody material, which is really different than what we have in some of the other treatments, which are fast growing grasses. And we also have a native planted prairie, so it's a mix of grasses and forbs or wildflowers, and several other kinds of treatments as well.
Now, is this, you said the project started in 2008. Talk about the it's obviously a long-term study. When do you expect to start having some data that, or do you already have data, and what is that indicating, if so?
The project is already yielding a lot of results in terms of the relative performance of the different crops, but we're interested in more than the yield alone. We're also interested in the long-term changes that occur when you convert from one kind of land use or cropping system to another. And in order to produce enough cellulosic biofuel to make any kind of a dent in our national gasoline consumption, we need to convert a tremendous amount of land to these kinds of crops, and the cumulative effect of all that land conversion could be important. For example, we're studying how the soil organic carbon stocks change over time if you convert from, say, corn and soybeans to this kind of agriculture, or if you converted from forest or native grassland to this kind of agriculture. And it actually would add up to a significant influence on carbon dioxide exchange with the atmosphere and ultimately climate change. So that's one example. We're also studying how the soils maintain their fertility and whether these systems could be propagated over many years with harvest taking away all that biomass, or whether new costs would arise, like the need to fertilize or control undesirable plants.
So are these production techniques that could be used on land that's already being farmed, or marginal lands too? Or are you looking at other untapped acreage?
These kinds of crops could be grown on cropland that we also use for food crops, but we're very interested in the potential for marginal lands to produce this kind of material, because you wouldn't be competing with crops grown for food, and that is a big issue that has arisen with this whole idea. So if we can actually develop crops that can be grown with relatively little cost and maintenance on lands that aren't being used for other purposes or are marginal in that use, that's a desirable target.
And can you talk a little bit about the impact on, let's say, the average person, average family? Why should they be concerned about the research, the types of research going on here?
Well, I think we all agree that we need to look to new energy sources in the future, that our current energy sources are not sustainable in the long term, at least the very long term. And so it's in everybody's interest to investigate all possible ways to develop alternative energy sources that can maintain our economy and our lifestyle at least as good as it is now. And this is one of many ideas. It may be a long time off before the average person can fill up their car with switchgrass biofuel, but it's an important area to research. And even if it does, it's not the silver bullet that gets us off of oil for transportation fuel. It can actually reduce the amount of oil consumed, and that's a good thing.
Right. What and that leads to the whole Department of Energy is backing a lot of what's going on, what's happening here. So that speaks to the impact as well and importance.
The investment of the federal government, Department of Energy in this case, in developing new energy sources is not a new thing. In fact, all of our traditional energy sources, such as oil and gas and nuclear and now solar, have been developed in the early phase with government support, and this is no different. So the idea is that they would foster research that would show the potential, and then the private sector would come in and take advantage of that to do something that would make a profit.
And how many acres do you have here?
We have 80 acres in this current set of plots, and there's a similar experiment set up in Wisconsin, maintained by the University of Wisconsin. And we also have some larger fields where we need to study processes that you can't study on smaller plots.
And how many researchers would you say are involved?
Well, the Great Lakes Bioenergy Research Center has a cast of thousands, but we do the sustainability part, and there's still a large number of researchers involved, both based at Kellogg Biological Station, based on campus, based at University of Wisconsin, and there's some other institutions involved. So the number must be in the 50 to 75, I think, for the most active people.
And can you talk a little bit about the importance of having a facility like KBS that allows you to do the work that you do as a researcher? I mean, that you might not be able to do somewhere else, the value of having a facility like this?
Well, first and foremost, we have the land base so that we can set up experiments, and we have people and equipment to conduct farming activities. This would be incredibly expensive to set up from scratch. So we were already in the business of doing agricultural research, and we have people very skilled at doing the farming, and we have the equipment and the experience. We have 25 years of experience down the road with our long-term ecological research project, and we have the labs to do all the measurements. And so this was a good investment by the Department of Energy because we were already set up and could hit the ground running.
Perfect. Anything else you think would be important to touch on? That we haven't?
Not that strikes me right now. We
Okay.
can go look at some other views real quickly.
Yeah, maybe we can.
Carbon dioxide and other greenhouse gas exchanges.
Okay.
Let me know when you're going, and I'll...
Yep.
Okay. So this is a grass that is probably one of the most productive grasses you could find. It's not native, but it is sterile, and so we think that growing it here doesn't present a risk of invasiveness if it were to get away. And so far it hasn't spread at all. Its name is Miscanthus, by the way, and it's native to East Asia. It's been cultivated for a long time for combustion for electricity in places like Europe. So that gave us the idea to put it in here and to see if it could be a good ethanol source. Yeah, it is.